Hello. So, the topic is powers, roots, and absolute value. So, powers is from this project, this text here. Close that. I do something like this. So this is for sure, again, something that all of you calculated before, but here's just the basic rules, how to calculate the powers. So if there is a number or even a letter and something written here in the corner, what it actually means. Then if there's the same base, then you can add them. And why is that? Here it's opened, you know. And then if it's something divided by something, then you can subtract. And why that would be, you can also write it like this, what it actually means when you have a power. So you just have as many of these numbers here multiplied, that is here the number. So if it's the 2, then there's 2 multiplied, and if it's 3, then it's 3 multiplied, and so on. Then here, yes, so you can also put the power to the both numbers. Why not? Or then you can also also for example, what something like this would mean. So if there's 2 things there, then there's 2 things here multiplied if it's the power 2. Yes, and then what else? If there's a fraction, then you can put to the fraction both of these numbers here, the power. And then if there's a power and then still a power, there are the brackets, then it means that you multiply this number with this number that was outside the brackets. And here is an example about it and why that would be. Okay, so it looks pretty well. There's just, I think this lesson is to learn these, to remember these rules. Not maybe, well, if you never saw them before, most probably you did. So to remember what they mean. Something in the power of 0 is always 1, whatever it would be. Oh yeah, and here is how you could figure this out as well. That would be always 1. Then there's a lot of examples how you do things. Then something negative in the power, that's like this kind of, how would you call this number? Compared to this number.
Power of 4.
Yeah, but 4 compared to 3 is...
Positive.
In Finland we say parillinen and pariton.
Odd and even.
What?
Odd and even.
Odd and even, yes. So if there is an even power, then it's always positive what you get, and here is also y. And then if it's odd, then you get always negative, and here is showed y. Yes, maybe you already remember, or at least for sure you have seen somewhere these rules. Then you can calculate without a calculator easily these things. So just to learn the rules of the powers, here is an example what you can do and how you can calculate some things. In the field of technology, it's often necessary to work with parameters, variables, letters. Well, yes, okay. So this is why we learn this. You have some kind of equations, and then you have to be able to work with the powers. They many times have some powers. And then there is really, really a lot of examples. Something from, well, not really, really a lot. Something from Khan Academy, for sure a good video. Yes, who is familiar with Khan Academy? Yes, I'm also theory. Okay, this is not that anymore. Let's go to here. Then the rules and absolute values from the same. Absolute value. Describes the distance from 0, obviously. And then here is how you, so this x, whatever it is, you know, these are like how you define this mathematically. But as long as you know, it's just this thing inside these lines is something positive. So then if you have something like this, for example, in this kind of lines, that means the absolute value of this, then you have to just put this the other way around, basically, because you need to get something positive, yeah? But this is just some mathematical writing. Blah, blah. We don't do this kind of considerations that much here. Simplify, simplify, simplify. Square root. I think there were just a couple of absolute value exercises. Then the roots, you know what is a square root, how to cancel the square root. So if you have the power of 2, it cancels the square root. And then you have to have, in the square root, you have to have something positive always. Or in the even root. And then there is examples how to do it. It's maybe better if you learn yourself. Then here a cube root. Well, that means that here is the number 3, which means that it cancels the power of 3. And then if you have an odd root, there can be also a negative answer of that. Mm-hmm. When you have the root, addition and subtraction must be calculated before taking the root. So if there's some additional subtraction here, you have to do that before the root. But if there's multiplication or division, then you can take the root from there. Then something else, what theory we should still know. Okay. Then also this, maybe we didn't look before, reciprocals, or maybe we talked about them and we have maybe even used them, but here just something. The multiplicative inverse of a number, as long as the number is not 0. So it's something, you know, if there's a, then it's that number, it's 1 divided by that number. Multiplying a number by its reciprocal always gives 1. This is also some exercises that you get there. And it can be also written like this, because it's the same thing. For example, 5 in the power of -1 is 1/5. So, or x in the power of -1 is 1x. You can't say it like that, can you? Or whatever it would be. This is a bit not that, it'd be better accuracy. So anything in the power of some whatever negative power, then you always put it under the line, and then you get the positive power. Or then if you put it back to this kind of, you know, like over the line, then you put the negative power. I don't know how to explain this. It's maybe better to try yourself. I think there's quite a lot of exercises. Well, so in total, there is quite a lot of exercises. There are the ones on paper and pen, and then there are also the ones in the little test, but the little tests are pretty simple mostly. Reciprocal of 2 is half. Reciprocal, if you have some kind of a fraction, then you just flip it around. -5, -1/5, and 0.1 is 10 because this is 1/10. Yes. So the reciprocal, you just flip it around. It's 10. Yes. 0 has no reciprocal. Yeah, division by 0 is undefined. You can put, what is it called? Okay, I'm not gonna say it because I don't know the word now. Solving equations, simplifying fractions, and reciprocal of reciprocal gives the original number. That's it. Let's calculate. So now you can pick yourself how you start. Here are the exercises, and here the little quizzes that should be pretty simple. And here is also a couple of absolute values exercise. I think here we don't have any. No, this is just, you know, this kind of, I realize what these things are. Things. And then this subject is done. So let's start with this. Practicing or starting to remember what these things meant that you sometimes learned in some school earlier in your life. And then, of course, if this is again really familiar and boring, then you can continue with the next topic. Yes. If, you know, you are really well aware what all these things are. The 0 in power of 2. Oh, this 2 in the power of 0. No, it's always 1. Yes, there was also it was interesting how this was shown here somewhere. Where was it? Maybe here. Was it shown? No. Oh, yeah, it was shown here. If you check it with numbers, yeah, it was just shown like this. So if something is in the same power, so you get actually the as a power of 0, and then if you open it, you get obviously 1. So this is how it's been shown here. For sure, there could be a bit more mathematical way of doing this as well. Or if it's just put here n, the letter n or something, I think that's the mathematical deduction for this. So if you would put there the power n, you already showed it that it applies for every single number. Because in these deductions, you have to always you can't use the numbers, but you have to put some letter so that it applies for every single number. So that it's always, the rule is always valid. Or how do you say it?
Yeah.
Yes. What would be actually our next topic then, if you thought that this was really simple and boring? But remember to do the quizzes because you get points from them. Well, then this is not that simple or boring anymore, for sure. There's a lot more to do in the next topic. Oh, I'm somewhere else. In the technical formulas, this can help you now. Sorry, this is in Finnish. Sorry about that, but you have the exactly same stuff for sure in this page 7 in English. You have the absolute value first. Then you have the square root. Then you have what the power, what they mean. Then you have the roots, basically. So this is first square root, the common root, or what is it called? And then the fraction power, which is the same, you can write the root as power that fraction. Maybe it would be good for me that I would have this in English now as well, so I would know the correct words. Maybe I go and get it. I can walk around a bit and you can calculate in peace, so I'm not talking anything. Okay, I go and get the book in English. It's better to have it. Oh yeah, then there are some power formulas, root formulas. Oh, this is now you see that this is a really good book, yeah. There's the whole page of this. Good stuff.
maybe the E.
Okay, so we are in, this is again, first of all. And 2,
Number 2 is E.
D.
E. Or
This? No?
it's,
Oh no, there's still more. Okay, I didn't even realize. Thank you. Oh no. There's even E. Well, I guess it would be easiest first to just put it the as a mixed number, yes? So then you would have 4, so you have, because this is 3/3, yes? And there's 1/3, so you would have 4. 4/3. And then this in the power of 4. Okay, and then that's actually quite a lot still. So then I would have here, of course, 4 in the power of 4 and 3 in the power of 4. And now I would like to use a calculator. Can you do it some other way? No. No. Just there's nothing you can do about this. You just have to because if you would think that, can I process this somehow? Because if you have the power of 4, then you have to have 4 of these, and then you have to have 3 of these. But there's no way that you can get rid of anything, can you? No. It's just, and then start to calculate it in your head. Maybe not. So it's just something. Basically, this is just to learn the rules. And so in some of these you can actually, and yeah, and I could really easily even with my super calculator put it just like this. And then there the power 4, and I would get just like that.
that's not the answer, right?
Yes, that's an okay answer.
I was trying to simplify it, but like, you know,
Yeah, if you try to simplify it, but there's nothing you can do.
Of course, here I maybe needed to do something because if I would have put this into my super calculator. Oops. Like this. Mm. No. Doesn't want to do this. What did I do wrong? No, I can do this with my super calculator. Oh, I have to do it on the paper. Disaster.
What kind of calculator do you find?
It's not like a super calculator, but it's pretty good, yeah. It cost I think 40 euros in the akateeminen kirjakauppa. And it's there's many functions in this that I have no idea how to use or I don't use. I don't need. If I would need, these are easy because then you can find just the guidance in the internet easily, and then you can just do whatever you need.
Yeah.
All sorts of statistical calculations for sure. All you can do with this as well.
Yeah.
But I don't need that for now, so. But this it couldn't do. This was too much. So, difficult is to see. For sure, my super calculator could do this. Where? -4. Which should mean that I have like -2/10, yeah. The power of -4. Which would mean that I have -2 in the power of -4. And then I have also, well, either or. Or should I go with the minus? For example, like this. Doesn't matter. -4. And then I would need to swap it, yeah, to get the proper powers. I could have swapped it earlier, maybe not. So then I would have 10 in the power of 4, and still -2 in the power of 4. Okay, but then if this is a minus and I have a even power, then it will be anyway positive. So then if I have a 10 in the power of 4, it means that I have 1 and 4 zeros, yeah? 1, 2, 3, 4. And then 2 in the power of 4 is 2 times 2 and times 2, which is 8 times 2, which is 16. Yeah? Two times 2 is 4, times 2 is 8, times 2 is still 16. So I have something like this. Now I can't calculate this in my head anymore. Oops. 4 zeros. Uh-huh. Okay. Did you get the same?
Yeah, I had to use a calculator. Yeah.
Calculator, yes. So then if I would do this with my super calculator, just like that, I would have minus 0.2 in the power of minus 4. Oh, okay. Well, I lost all the nice parts. Nice parts of the figuring out what it would actually mean. Well, the D, of course, could be done here as well because it looks a bit like, you know, there if you have something A times B on the power of, so of course that's like A times that this was always 1, so it's A. If it would be this A, B, and in brackets, then it would be just 1, yeah? Yeah.
See for the B.
3B,
Yeah. When you work one,
there.
yeah, 1 over or 1 to the power of 149, then over 6 to the power of 149.
This?
Yeah. If 1 just cancels out, it's just 1.
Because it's just 1.
Yeah.
Yeah, you can multiply the 1 with itself as many times as you want, but it's still 1. Yeah. So it's just, and this actually means if you have something here as a multiplying thingy, this you can mark it in the way that it has the 1 under if you want. Or then you can just expand the line. It's already there, you know, whatever. Well, the 1, you know, and you can also, yeah, multiply the 6, whatever, with 1, and it won't mean anything. And then if you had something under the line as a, what was it, denominator, with a power, then the power, if you put it as a, what is the word for over the line? I don't remember these terms in English.
Numerator or denominator.
Numerator. If you put it as a numerator, then you have to just
Negative.
put the negative power. Yes. I think it said here as well. This tells you now everything. If you don't remember how these things went, well, this is just the other way around. Something with the negative power is 1 divided with that, but a positive power. Well, in English, maybe I'm not explaining it. I can't explain it really clearly, but for sure when if you're then you have long like equations in some field with letters, you have to be able to do this kind of things. Now we do it with numbers. Maybe it's not something in the power of 150 though. But still you just figure out how it's done and then you can do it with the letters as well.
Gonna see or eight, they're the same.
Do C
Yeah, and then.
This.
Eight.
for, oh yeah, wow. Well, you can do it twice as well. Why not? That's obviously a good exercise.
And it will be especially embarrassing now if I get it wrong.
Yeah. Paper calculator wouldn't calculate this either. Oh, it did calculate this. Not bad. This is something that then when you have some long equations and then with letters, you will come with something like this. You need to then be able to modify to something like this. Here it doesn't mean anything, but then of course these letters mean something. So here is a couple of things that you can sort of cancel out, like here is 8 and there is 32. Yeah, so here you can do like this. And then you can do like this. For example, you can mark it like that. And then there's the A power, and then there is the B. And that's it. Or then you can also figure out why it went like that. So there is this again. So you have 32. Then you have 5 there, 5 A's. And then only one B. Then you have 8. And then you have again A times A. So then you can figure out that, okay, these ones at least I get away because they are over the line and under the line. In the numerator and denominator, the same stuff. And here also one could have figured out still something more, that the 32 is 4 times 8. Now I already canceled those. So then I still have the A times A times A and B, and here I had the 8 still because I canceled those A's, and now I realized that also I have same stuff there. So then I get 4, and when there's 3 A's multiplied with each other, then you can mark it a bit more shorter way like this, and then the B. Yeah, this makes sense. Yeah. So this is the like learning the mathematical language again. So yeah, this is just sort of a shortening expression of something like this. It looks a bit nicer like that.
Easier with letters, I think. I find it easier with letters than numbers.
Okay.
You know, I keep trying to think about the numbers, like, you know, if it's 2 squared,
Mm-hmm.
you just immediately 4
Mm-hmm.
times.
Yeah, yeah. Yeah. There's the root still. Fractional exponent form. I don't know if this is a correct English, by the way. Because here it says rational power. Rational power. Is this something that Donald Trump should have? Well, now he's doing some good stuff in Israel.
I don't know.
Yeah, we'll see how it works out.
So what like the deal with them, you know, who plays golf.
Oh yeah, he plays golf all the time.
Like I like golf. It was when he's putting, it's like some really bad looking technique.
Really?
Yeah, well,
Well, he's supposed to be good in golf, yeah?
yeah, but he's not famous cheaper at golf.
Ah, okay, yeah, that would make sense. Rational power. This book knows everything, you know. It also knows about rational power. That's something we should all learn, yeah? Does this mean? So it would look like 1. This was the reciprocal thing. There was the power of -1. That was called also the reciprocal, one way of marking the reciprocal. So then 2, power of 3 there, and then the reciprocal of 2, which is of course 1 divided by 2 or half. So here you couldn't, of course, because there was, I guess this exercise is there so that you don't start calculating the powers together now, because there are these subtraction and addition, yeah. Just to mark it out. And then I would need to do the, the calculating the fractions together. So everything would need to have the same denominator. So I would need to do this. These things there. 2 8s and 1 8 and 4/8. And then I could have 5/8 finally. Okay. Why not? Oh, that is also interesting looking. -2x.
Could I ask, see what I saw, so if it's the negative power, that always means the one's on top.
Yeah,
Yeah.
unless this would be a fraction as well, yeah.
Yeah.
So then it's like both,
Yeah.
you know, to the negative power, and then you have to flip it to
Yeah.
get the positive power.
But then if that's the negative, why is it still, if you have to, you know, like, but why wouldn't the, you know, like to negative become positive?
What do you mean?
So like, you know how like if there's 2 to the power of 3, no. Yeah, negative. My understanding would have been like, you know, if it's negative 2, then you know, if the like as opposed to 3 things negative 2.
Yeah. That's
Ah,
the here it would be 3 of them.
Yeah.
Yes. It's also looked interesting. So obviously I would need to remove the brackets first. I can still calculate these together as well if I want to, but whatever. I'll just remove the brackets first, which would be times. Now I get still minus. So -2 times -2 times -2 is like -8, yeah. And then I still get the x in the power of 3. And then I can start just putting together the numbers and so -2 times -6 is I got -12. And I can put them like this, for example, and then the x's I have got times x in the power of 5 times x in the power of 3. So I just calculate the powers together here. So this is, of course, the minus sign is off because there's 2 minuses, and then this is like 80 plus, so it would be 96, yeah. And then times x in the power of all of these together. So here would be like 1 plus 5 plus 6. That would be in total 9. Yeah. Then there is some kind of reciprocal again. Reciprocal, which is the 7a 1 times g 1. Oh, well, okay, does that look like g? And the power of -1, which means, of course, g, yeah? Well, usually the g is this. This.
Yeah.
I'm sure this is also, these are some old calculus exercises from the teacher who has been teaching these courses for a long time, and then for sure, for example, something that like this has been difficult for the students in some other continuation course to figure out what it actually means. So that's why this kind of exercise has to be here.
Yeah. So it just equals them.
Just equals that. Just equals what? This?
Yeah.
Well, it can be the G can be anything, but it's usually this, isn't it?
But then, like, in that situation, why would you just write G?
Yeah, exactly. So this is why wouldn't you just write G? Because this is something that has come for sure. Why is this here? Because this is copied from this
Yeah.
teacher who has been teaching these courses for a long time. For sure, something like this has appeared on some equation, longer equation on some continuation course.
Yeah.
And it has caused a lot of problems.
Yeah.
So that's why it has been taken to the maths course. So that they just realize that it means
Yeah.
what it means,
Yeah.
you know. Like, because might happen into this kind of, you might have this kind of a situation when you're modifying some long equations and suddenly you have something like this, and then you're like, what does this mean? Yeah. Yeah, it seems weird, like on this context, but it must have some reason
Yeah.
why it's there. Okay, the B is really simple, and then the roots. Fractional exponents, that's all. We are almost in the end of this. And these were the more difficult exercises, the ones in the quizzes are more simple, yes. Roots. That's ace. Okay, whatever. So you have to, you can't just take a root because it would be nice to take a root of both, yeah? But you can't because there's the addition. So now when you add them together, it becomes a bit like boring stuff. Now you can't take the root easily anymore. For sure, this has been something that students have been doing as well on some other course. And now it's there. Yeah, like, you know. And then of course, with your calculator, now this is the exact value, and then you can get the inaccurate value, which would be something like this. 5, whatever, blah, blah, blah. Now one knows that one can put it all into one root, yes. Just like that. And why would it be, well, okay, and then you can then divide this, so then you get 3a here in the root, yes? Because you divided 6 with the 2. And why would you be able to do this? Because it means the square root. Where is this in here? Yeah, it's always the fractional, rational power. The really nice sounding express rational power. which would mean that if I have the same root here, I would have actually divided by 2, so then I would have 6a in the power of half, yeah, divided by 2 in the power of half. Then the both are with the same power, so I would have, I could put them also 6a half. I could do it like this as well. Because I know that the square root of x is x in the power of half. Yes. Or a cube root of x. Cube root of x is x in the power of 1/3. Something like this. Or a cube root of x in the power of 2 is x. In the power.
7.5. Or
Yes. Yeah, don't, or this is like what it means, sort of. I don't know. This is again learning the mathematical language. What these things to mark something like this means. Or you can mark it the other way as well, or if it makes more sense to you. And you have it all in here in your technical formulas. Good book. Well, first, you know, certain things you can calculate this many ways. Da 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 times the same thing. For example, like these. So then you know that the minus cancels out, and then you have 2 of these, so you get, for example, this like this, or you can then, and you know that they cancel each other, so then you have half. Yeah. Mm. Or you could have done many in other ways as well, this consideration. Now I guess there's no other option but to do it. Yeah, this is how, maybe how to use the calculator, exercise how to use the calculator. So you can have maybe, I have this kind of nice thing here. So I can even do it like this. And with all of the calculators, it's not possible. And I get it. Or then I could also modify it like this. in the power of 1/6. And then I can put it in the calculator that way as well. Oops. No, I would first the 7 to 9 and then here the fraction power. And I get the same answer. Seems to be 3.
That's number 6, I don't understand.
This.
Yeah, that's one. So,
It was just the 6th root.
okay.
6th root. It doesn't look great. Maybe this should be here. 6th root. Whenever do you have the 6th root? Maybe send some long equations. Maybe you have many weird stuff there in the equations. So what can you do? Well, here you could do many things, but then you come in the conclusion that Ba-da. But this is a bit complicated matter because you have an even root and a negative number, so you can't do it without complex numbers.
Yeah.
No answer. With our knowledge, yeah?
Why would
Because of this.
root of a to the power of 4? Not it.
Because these cancel each other out.
Yeah.
Because you have, if you have a 4th root of a,
Yeah.
this is if you write it as a fractional potence, rational power. It's like this. So then you have a in the power of 1, which is a, yeah?
Yeah.
We are almost in the end.
Yeah. It's like I have so much trouble doing, like this kind of stuff at home. And it seems very easy, like when you're describing it, I think, I don't understand why it was difficult at home.
Yeah, because it just looks complicated. A lot more complicated.
Exactly.
Yes.
It's like learning a new language.
Yes, it's
That
just
someone tells you how it is, it sounds very logical, but you just have to.
then when you try to talk it yourself, then you're like,
I have the same problem. So, checking the rules again.
okay, thank you.
Bye.
Bye. See you.
Yeah.